Okay, so let's discuss the rules for the nth term in a sequence modelling geometric growth or decay. In other words, how do we find the nth term in a geometric sequence? Right, let's use an example in which we've used the recursion relation, and we go through it and we see how we find this rule. So if we invest $8,000, remember invest means putting it into the bank or something like that, paying 6.5% per annum, compounding yearly. That means the interest is calculated yearly or annually. Remember that compounding says how often we calculate interest. So for this example, we're just compounding yearly. So setting this up as a recurrence relation, we've got our VO is $8,000 and our recurrence relation rule is Vn plus 1 equals 1.065 times by Vn because it's growing. And yep, 0.065 is how we write 6.5% as a decimal. Okay, let's go through the years and see how we calculate this. So we start with the V0. Then we get that V1, which is 1.065 times by V0. V2 is 1.65 times by V1. But let's have a think about that. So it's 1.65 times by V1, and we thought V1 was 1.065 V0. So in other words, V2 is equal to 1.065 to the squared times by V0. Then V3 is 1.65 times by V2. So 1.65 times by 1.065 squared times by V0. So V cubed is equal, V3 is equal to 1.065 to the 3 times by 0. And I'm sure there you can see the pattern. So V4 is equal to 1.065 to the 4 times by V0. And that's how we get our rule. This is for compound interest and loans and investments. So our Vn is equal to V0 times by R to the n. And our R is 1 plus that rate divided by 100. And n is how many compounding periods there's been. We have the plus there when we are earning the interest, when interest is going to increase the value. So if we're increasing the value of an investment or a loan, so you incur interest, so the value of that loan is going up as well. How much you owe is going up. With depreciation, we minus it. Okay, so please be careful there. So let's look at this second example. I've got $3,200 invested for 5 years at 6% per annum. Interest is compounded quarterly. That means we pay the interest quarterly 4 times a year, so that's every 3 months. So find the number of interest-bearing periods, n. So 5 years times by 4 quarters, 20. So we've had 20 compounding periods over this time. So find the interest rate per period, R. So 6% is our per annum rate. But because it's compounded for quarterly, 4 times a year, we've got to have that split over the 4 quarters. So that's why I've divided by 4 there. 6 divided by 4 gives me my 1.5. So our interest rate per quarter is 1.5%. So find the balance of the account after 5 years. The balance is how much is the account worth? How much is in your bank account? How much is that investment worth after 5 years? So I write out my formula. There are my knowns. That's what I know. And then I substitute them in. Okay, and obviously I've worked it out here, but you can use your calculator. So V20 equals 3,200 times by 1.015 to the 20. Now, please make sure there when you are calculating this, you only raise the 1.015 to the 20. I've seen students make that mistake where they've got the whole thing raised to the power of 20. So that means we end up with a V20 of $4,309.94. Now you really have to take note when you're reading this type of question of how much is initially invested, how long for, what the rate is, and if it's a per annum rate, and how often the compounding periods are. So you have to be reading it carefully and picking out that information very carefully. I'll pause there, and then next video I'll talk about our past exam questions.